see if my share screen works.
Well, I think I allowed participants to share screen.
All right, is my screen shared? Let's see.
Yep, we got it.
Okay, let me get to the slide. Oops, sorry about that. So is everything visible? My first slide?
Yep, perfect.
Cool, great. So I'm ready to start. I want to give a little brief background on this Wildfire Communications Challenge. And what we're going to try to do today is give you a brief presentation on some of the challenges that exist within the wildland fire community and how they exchange information. These are primarily wildland firefighters that are working on fires, not urban fires necessarily, but on, as I said, our wildland fires and how we can increase the information exchangeability between them and go from our current way we operate, which is over walkie-talkies and over radio systems, to improve that capability and to try to kind of bring our wildland fire capabilities up to the 21st century, if we will. Kind of start out by saying that wildfires are very important due to the climatic changes that we've seen across the globe. Warming conditions have increased fires, increased the number of fires and the intensity of wildfires, and of course destroyed property and modified our environment, both our shrub ecosystems and our forest ecosystems throughout the world. This is particularly a critical issue, obviously, in California. And so what we're going to look at is looking at how we can increase the information sharing on those wildfire events between incident commanders that are on the ground in a control center and the wildland firefighter who's out in the field. Fires are difficult to really manage because of the distance they are from available resources and lack of real-time information sharing, technologies like communications linkages, cell access, cellular access, and also because of rugged terrain, which hinders communication information sharing among fire management personnel and all of those that are working on the fire lines, kind of quite a bit of distance from the wildland firefighting assets in the field and with their management teams, pretty far away. And so those communications are not really well done currently. And we're looking at ways to improve that information exchange. And that information exchange includes exchanging data and information from other resources that we might have. So it's not just voice sharing of information like, hey, I think the fire is over here. It's sharing observations that we can make from satellite data sets and also from airborne aircraft flying overhead with sensors on board that can geolocate the fire and share that information with the wildland firefighter on the ground. So he has an improved situational awareness of what's going on around him. The data sets also include localized weather station information to help them make effective decisions on where the fire might be moving to, providing perspective on the terrain that they're in, road networks, values at risk, such as houses in these wildland urban fringe areas. So although radio communication is really important, I think what more we need is communications in the new digital world that involves data sets, both raster and vector data sets, to transmit and share visual data and information with that wildland firefighter. And a lot of times this information needs to be provided in real time or near real time. So I'll take you through some of the challenges that we have with discovering where that data is and then trying to build a usable app that is cross-platform application for mobile devices that the wildland firefighting management community can take advantage of, possibly.
And Vince, you might want to mention also that there's a nice linkage to SpaceX on this because the Starlink satellite system may be a really nice new asset to provide digital linkage. And because right now they rely on analog RF systems that are limited, particularly in certain terrain areas. So Starlink may be an important part of this solution set.
Yeah, very good point. So, it's building the data set, building the applications that coalesces all this disparate data that is being collected that a lot of people really don't know about. Another critical issue in all of this is the sharing of that information. As Dan said, one of the major issues is that we cannot really rely all the time on cellular networks because they're inefficient and they don't operate very well in these remote environments that don't have cellular towers and the like. So we're looking at other communication protocols to enable the sharing of this information between firefighters themselves out in the field, and between firefighters and their incident command center, their management teams that are basically like the Pentagon of the warfighter. So we're trying to integrate communications concepts that marry the Pentagon with the warfighter. In our case, it's marrying the Pentagon of the Incident Command Center with the warfighter, who's our wildland firefighter. So those technologies may include, doing satellite communications where you don't have a cellular connection or Wi-Fi connection, which you don't obviously in these major remote areas of, let's say, the Northern Rocky Mountains or even parts of California, obviously. So I'm going to take you through some of these challenges and give you little hints upon where data might be gathered or collected from, and then let you run with the concept and see what you develop out at the end. So with that, I'll kind of head into my first slide, if I can. See what I get. So why am I in this field? So I serve at NASA as a wildfire research scientist. And you might think, well, what's NASA doing in wildfire research sciences? Well, we look at observations from our satellite platforms to increase our information, to understand the science behind wildfires and why they are increasing in intensity and growth. We also look at being able to measure wildfires in real time from our satellite platforms and our airborne platforms. So how did I all get started? So when I was a kid, back in the 1960s, way before many of you were born, or all of you were born probably, I always wanted to be a firefighter. I would chase the fire truck that would run down our street to act on emergency situations that are going on in my neighborhood. So I always wanted to be that hero firefighter that was involved in saving people, saving structures. And that gradually advanced to the point where I wanted to be an astronaut. So this was the start of the NASA manned space program in the early 1960s with Mercury, Gemini, and Apollo missions, and our plans to go to the moon in 1969. So, I had this dream that I wanted to be an astronaut someday, still in the back of my mind having that firefighter bent. But I ended up being kind of achieving both ends of that perspective. I did work as a wildland firefighter for a year while I was in graduate school. And then ultimately I took the job at NASA to support Earth observations, in particular in support of natural resource management. And then my interest in wildfires naturally took me to work on these concepts of observing wildfires from our newly created satellite network of imaging systems in space to allow us to keep an eye on wildfire growth, where wildfires were, and to do various assessment of wildfires. I then took that as a challenge to say, well, how can we take some of the science and technology and information that's out there from our satellite data and our aircraft data, imaging data, and how can we apply that to real world situations? In other words, how can we help the wildland fire community understand wildfires a lot better? And not just from the research perspective, but from the management perspective. How can we manage fires much better? So that's what got me into this whole realm. And I now serve for NASA headquarters as a wildfire scientist in the applied science program. Applied science is exactly how it sounds. We take the results of our research endeavors at NASA and bring them into applications uses or fruitful uses, into operational uses with our wildland firefighting community. So that's the application. We're taking these technologies and applying them to real world situations. as an intro, let's kick into what some of the challenges are that that I see within the kind of talking concepts that you will hopefully be working on over the next day or so, and seeing them as a challenge to develop appropriate applications, mobile applications that might be helpful to the wildland fire community. So a little bit of background. So what are the challenges? The wildland firefighter, you got to remember, is basically out in the field alone or with his firefighting team, and he may be remotely located. He may have parachuted into a remote location. He's not necessarily, he or she is not necessarily coming from that area or lives in that area. He could be deployed to that fire from another state, knows nothing about the region that he's being parachuted into or being driven into. So we need to have some situational awareness for that firefighter. So information like where the fire currently is, where do I get good nearby weather data? There's a number of weather services, and I'll provide information on where those are that that firefighter can make use of out in the field to understand the fire weather conditions that are going on around him. Wind speed, wind direction, information like that, which all are driving components of the wildfire environment. Where are my fire resources located? Incident management in some cases knows where this is. You know, they're sitting in a tent somewhere in a fairgrounds away from the fire, probably 4 or 5 miles away from the fire, maybe farther. And they kind of know where resources are through radio communications. But that wildland firefighter out in the field doesn't know where those resources are. He doesn't have a perspective on where they are located in relation to where he is, that he might be able to call in the nearest resource to him. So those resources include fire trucks, helicopters, fire aircraft, manned aircraft flying overhead, water sources. Where are there potential water sources that we can utilize to help fight this fire, to fill up our pumper trucks, to fill up our retardant aircraft so that they can go and release that water onto the wildfire environment? Where are my fellow firefighters? You know, one of the big issues is to have awareness of where your whole team is around you. How can we track all of that? Obviously with GPS systems, which are embedded in many of our phones and other items, but how can we make that information shareable with everybody out in the field? So we can see that, oh, I'm a firefighter. I see that I've been separated now from my fire team and I don't know where they are. I can locate them on a smart mobile device from their GPS locations and realize that they're 500 yards away from me over the top of this ridge and down into the next valley. So information content like that is of critical importance. As I said, where are the roads? Where are the road networks? How can we access this fire more readily if we don't have information that relates to our surrounding terrain and where the road networks are to call in these resources that might be mobile based, whether it's a bulldozer or a fire truck or emergency rescue operations teams. So to have situational awareness of the environment around you when you're all of a sudden in the middle of the night, dropped by helicopter into a remote area or parachuting on the back of an airplane as a hotshot crew going in to attack this fire, and you're going to be on this fire situation for maybe up to 14 days in the backcountry. And you have to have good situational awareness where your access routes are, how to get in and out, where other resources are. So that's why these are critically important. The other thing we worry about and need to be aware of as a wildland firefighter, where are the structures at risk? Of course, you know, in the many remote areas, there's no buildings or structures at risk, but we're starting to see, you know, with the spread of population and everybody wants to live in the wildland urban interface with nice trees around them. But this poses a severe potential problem for those structures also being involved in wildfires and, you know, burning to the ground. So as a wildland firefighter, you need to know where those structures are out in the woods so that you can take effective action at either helping to evacuate people or mitigating that fire, keeping that fire away from that structure at risk. Structures at risk can also include our own natural infrastructure, power line right-of-ways, maybe gas line right-of-ways, things that are out in the field that are part of our energy sector that helps to keep the power going to our communities, water resources, things like that. So those are all important as well. And then, as I mentioned, kind of an overarching view is what are the characteristics of the area? What's the terrain of the area? Is it hilly? Is it steep, mountainous terrain? What's the vegetation communities like? So all of these information data layers are important. And then, of course, how can I communicate and share all that information back to my fire commanders and managers at the incident command center? In other words, I need to tell them, here's where I need to put resources. We need to have a retardant drop from an aircraft or a helicopter at this particular location. Now you can specify that over the radio, but if you don't have radio contact due to the inability of transmitting that great of a distance with your radio, you have to have some means of communicating, let's say on a map, and pinpoint a location, say, this is where I need my fire retardant to be dropped. So we want to do all this across multiple smart platforms, phones, tablets, laptops, etc. But these are kind of the main focus areas of what we want to try to achieve in this challenge is how can we develop an app that's available across multiple platforms? And I'll give you some examples of that to work from and the data sets to work from. So where do we get our data? So our satellite observation data comes from a number of different sources. We have daily coverage from satellites over the entire globe on about 4 to 8 observations a day, spread throughout the day of wildfires, and that's for the entire globe. We use 2 satellites called the MODIS sensor system on Aqua and Terra satellites, and you can see their orbital pass times. So they're passing overhead in about another hour and a half over California at about 10:30 approximately. And we also have the VIIRS, 2 VIIRS satellites, and you can see their overpass times there as well. So between these sensor systems or observation systems in space, we can get about 8 views of a satellite of a wildfire environment over the entire globe per day. Now, you know, the resolution of that information is not quite sufficient enough to allow tactical fire management by the fire management community, but at least it gives them a perspective on where there is fire at that snapshot moment. So with that, you don't, realize that we have resources available, but the place to get those resources and where it's served is through the Fire Information for Resource Management System, or FIRMS. So this is one of the websites or web services that we'd like to be able to link into this data sharing capability or information sharing capability web service app. So this is basically a real-time web service map that locates from those previous satellites that I just mentioned to you with updated information on where fires are throughout the globe. In this case, this firm system is set up for the United States and Canada and Alaska use. And this is currently being used by, as you can see, it's a shared resource by NASA and the US Forest Service. This is in final beta test mode, but it is basically operational. It's operational for the entire globe. And we're just transitioning it over to the Forest Service as their operational system for locating fires and therefore allowing them to deploy resources. And you can, go into this map service and zoom in on a particular fire event, see when that hotspot was initially seen or observed, the confidence level on that wildfire spot, and you can zoom in very close to see individual structures and road networks and the like. So this is a nice information sharing tool that we want to have available to the wildland firefighter. Obviously, the fire management personnel at the incident command centers make use of this kind of information, but how do they share it with the field personnel? Well, they do it over radios. That's not efficient. So if we have this information available to the wildland firefighter out in the field as one of the resources he can look at, it'll basically shorten the information exchange potential time period and reduce that communication, whatever you want to call it, fuzziness, and therefore get distinct real-time information to that firefighter that he really needs, he or she needs to take effective action on their wildfire firefighting activity. What else can we use? What else is important? There's something called the Remote Automated Weather Stations, RAWs. We know them as RAW stations. So if you can, if you want to look up and Google or track down what RAW stations really do, they're basically there are 20 that are strategically located throughout the West. In California, we have about 300 or so, I believe, weather stations. And these are portable weather stations. You can see the images on the left of what those weather stations look like, and they're weather stations out in the field. And those are remotely located at fixed positions out in the mountains, and you can access that information over the internet from any particular station. So accessing the RAW's weather data by a field personnel would allow them to say, hey, I want to see where the nearest weather station to me is, maybe a mile away. I want to see what its current weather conditions are, what it's been tracking as the weather conditions over the last 24 hours, and the like. So that information is readily available. It's served at the RAW's website for any individual station. You could click on it and get the current weather conditions. All that information is relayed from that weather station. They're solar powered weather stations, and it's all relayed through satellite communications network systems. So it's very simple ASCII data that provides a number of different data layers that are important for the well and firefighter. So that's another good data layer to have access to, and with internet access or with Wi-Fi access or cellular access, one could get a hold of this information, but it is of critical importance to the well and firefighter. Again, at the bottom of that slide, you can see incident remote automated weather stations are also deployed. So there's a number of these weather stations that are backpackable by field crews, and they'll take them out onto a particular fire event and set them in locations that can provide critical information on that particular wildfire event if these remote automated weather stations aren't close enough to them to make effective use. They may be 5 or 10 miles away, and it might not get representative weather readings of the fire conditions that you're in currently on the other side of a ridge or 4,000 feet in elevation different from where that weather station is. So the ability to access these remote automated weather stations is also kind of critical and important. Global positioning data. How do we locate various assets? How do we locate as I mentioned in the earlier slide, how do we locate our firefighter assets that are out in the field? These are groups of teams of individuals, fire hotshot teams that may be anywhere from 15 to 25 or 30 personnel that are working together remotely out in the field. How do we stay in contact with those firefighters and know where they are? In case we need to warn them, hey, you've got a critical fire that's raging over the ridge coming your direction due to a wind shift. We need to get you out of there. Knowing where everybody is of critical importance. So that may be units on people's mobile devices. It could be little small units or chips that are embedded in their uniform or in their pocket that allow somebody to be GPS located. Fire equipment, where are the fire trucks? Where are they deployed to? Are they going in the wrong direction? Are they not on a proper road that will take them to the fire front to effectively fight the fire? Where are the fire retardant planes, and when are they going to be making their drops over my area? Be able to track those moving assets from the air, and all of those assets have or are pinging their locations as they're flying. So how do we get that information accessible to the firefighter on the ground rather than just his management team back at the incident command center? The fire helicopters as well, fire retardant planes, fire retardant helicopters, makes sense. So other things that might be really interesting is locating where water sources are, where people's swimming pools are. A lot of cases we'll make use of whatever water resources are available for our dip buckets for those helicopters or even airplanes to go in and extract water into a bucket system to use to mobilize and move over to where the fire is and drop that water resource onto that fire event. So some of these kind of critical information on where locations of various specific information or data sets or personnel or resources are so that we can track them on a kind of a one-stop mapping web map service or application. Here's the mapping data services that are important to us. Topographic map data. Maybe this is 3D perspective images like you are enabled by Google Earth, but basically to see the terrain around you and to therefore, if you have intuition about where the fire might move, moving more rapidly upslope versus slower downslope, you need to know the terrain of the region so that you can understand where to place your resources or to make effective firefighting decisions. And again, I mentioned the word networks. How can we share the road network information, and not just city streets and highways, but the Forest Service road networks that are scattered throughout the Forest Service lands, the Bureau of Land Management lands, these remote areas. And what's the quality of those roads? Can we get a fire truck down them? What size fire truck can we get down them? So basically having a layout of the road networks is important. In this case, I'm showing the US Forest Service road networks, and that's probably one of the most critical elements that we could have. And then structure location data. To know where our structures are in the wooded environment or the fire prone area environment, know what buildings are there, know what homes are there. And in some cases, maybe even if we can get to it, who are the occupants of that? Are they elderly occupants that we need to help evacuate? Are they people with chronic health issues that we may need to evacuate much sooner, or that might be potential loss of life in that home because they can't get out of that home by themselves? They may be wheelchair bound. So information like that on structures and potential population that are included in that structure. So as you can see, like as I've mentioned throughout these slides, communication is essential. But what we have right now is not up to date, and we're not fighting fires effectively because of that. And we have the technology. You guys know about it. You've been using these technologies ever since you were young. Internet connection, internet speed, sharing of data sets, sharing of map data, sharing pictures, sharing imagery. So, but the wildland firefighter knows about these capabilities too, but they haven't integrated it yet. They haven't found really good solutions to make that crossover between that incident command center and the wildland firefighter out in the field. You can see the incident command center, they're operating off paper maps, and more recently, they're operating off of digital map services and data off the web. But how do they exchange that information that they have, like behind the backs of that incident commander, those map-based information? How can they share that kind of information to the wildland firefighter out in the field that's got to decide on his own, he's all alone, or with his team of 19 other firefighter members in his team, and they're trying to make a decision on where they should go or how they should fight this fire. And so that exchange of critical information over those great distances is very important. How it's currently done is via the radios. You can see a couple of radios usually carried by the firefighters. And you might think, well, that's pretty efficient. It is, but imagine that each of these radios holds 8 to 10 AA batteries. How many do they need to carry on their person to make that radio operational for them during their, let's say, even just one day in the field? They're carrying usually 3 to 4 total sets of batteries on them just for one day of operation of that radio in the field. Now, if you're a fire hotshot crew and you're in for 14 days, how are you going to carry that amount of massive materials with you into the fire area to enable you to communicate for those full 14 days? Or a lot of times these might be put on a pallet. These batteries would be put on a pallet and hung over a helicopter and brought into these remote locations in the field and deliver them as provisions to these firefighting crews. But you have to know where to send them and be able to identify your GPS location, say, hey, here's a good spot to make the drop of these batteries for these radios. Please come and provide us with our communication enhancement tools.
Well,
So,
and Vince, you might mention also those radios are analog, so they're voice. They're voice information. It's not digital. They're just voice communication.
That's right. They're all analog radios, and so the cache of radios, and that's the supply of radios that the U.S. Forest Service has at the National Interagency Fire Center that they distribute to all these fires throughout the country. is well over 20,000 radio systems. So imagine the expense of maintaining these radios and with supplying batteries for the radios and the like. So we want to be able to enable much quicker and efficient data sharing within our community. So can we develop an app that modernizes our wildlife firefighting forces? So what we want to do is we want to take us from this incident command center on the left-hand side, communicating through field personnel in that center image via radio. And then you see the bottom picture is a fire commander's truck out in the field, and he's got 3 or 4 radios there on his center console, and he's got a notepad, and not a digital notepad. It's a pencil and pad of paper for him to take notes and for him to relay that information over the radio to his crews out in the field. That's not very efficient. What we want to get to is this. We want to see wearable mobile devices, sharing amongst various mobile devices, whether they're iPhones or Samsung, whatever their operating systems are. Be able to share this map data, real-time tracking capabilities you see in that one system there on the left with the green tracking arrows, breadcrumbs to locate where a fire truck is moving through a particular area, locate the hotspot detections on those maps, locate other resources on those maps, or even to the point of having a tablet system, an iPad or the like, to have basically a cross-platform web-enabled or information exchange-enabled application that is ubiquitously served over any different platform that a firefighter might bring to the fight. With that, what is this all going to do? It's going to make life safer for the firefighters, obviously. It's going to create the ability to fight fires with more modern situational awareness tools that exist out there, but we haven't incorporated it into the wildland firefighters communications packages or information exchange packages. It's going to reduce fires much quicker with the intelligent response capabilities. You won't have to have firefighters wandering around in the woods trying to find out the area that they're supposed to focus on for their firefighting efforts. For them to lay down retardant or for them to create backfires to stop the advance of a fire front. So they'll be able to respond quicker and contain fires much quicker. And with that information capability that's exchanged between central server processes, such as the satellite data, the RAWS data I said, aircraft data might be coming, imagery data might be coming from unmanned helicopters or unmanned aerial vehicles that have sensing systems on board them similar to our satellite data. That information can be provided instantaneously to the firefighter beneath that aircraft on the ground rather than just going to the incident command center, and then the incident command center figures out a way to relay that information to the firefighter out in the field. Let's cut out that middleman and get that information exchangeable and available to the firefighter on the ground. Also allowing the firefighter on the ground to respond back to incident command to give them the current view and the current situational awareness of what they're seeing in the field so that the incident command can make improved decisions on deploying additional resources if necessary. So it's a matter of a two-way street of going from the Pentagon to the warfighter and then the warfighter back to the Pentagon. Save resources and property. Can you imagine the advantage you might have or as a firefighter if you know where resources are out in the field, you know where people live, you know where property is threatened by this fire, and you can go in and take protective action on that event. Or even the resources could be our wilderness resources that are available to everybody for hiking, fishing, hunting, exploring, camping. So we want to make sure that those resources are not threatened as readily, or as much of the resources are threatened through quick remediation activity on the fire by firefighters who have the situational awareness tools in their hands to affect that saving of that resource. And then finally, that's the challenge. So I look to all of you to create something very interesting, and we'll be staying online as mentors off and on, or we'll plug in off and on during the day and answer any questions you may have. But I'm willing to let you go and discover what are the potentials and feed those back to me. You may discover new capabilities that we don't even know about in the fire community that we might take advantage of. And as Dan Rasky said at the beginning in my slides, is you can also explore some of the communication potential that's out there. How do we make a small enough system to communicate with satellites that isn't big and bulky and does not have to be carried on a truck, let's say, out into a field environment to set up a remote communications platform access to either a remote Wi-Fi or a satellite communications link. So, throw some of those ideas around and see what you can come up with. The critical element I might mention to you is that our radio communications are a bottleneck to our information sharing amongst our well and firefighter and incident command. We need to get rid of that bottleneck and that loss of data and improve it with the capability to communicate potentially worldwide over either satellite links or Wi-Fi links and exchange real-time digital information, which might be maps, analog data, tracking devices, or the like, over modern communication mobile devices. So with that, I'll stop there and free up my screen. Any questions or anybody before we kick this all off and I set you free?
Yeah, any comments, clarifications?
I have a question.
Go ahead.
Yeah, so this was really fascinating for me, especially because I recently also had another lecture from a representative of a private company who also has like their company send satellites to space and use imagery. So I'm wondering, like, since this often your operations rely on these satellite imagery, do you cooperate with the private sector or do you have a different goal? How does that work?
So yes, we always work with private communities. That's kind of one of our particularly important assets within NASA. As a federal agency, or even within the fire community, there's always collaboration with industry that are on the cutting edge of technology developments. Some of that industry sharing and industry science or awareness is enabled by programs within the major federal agency, SBIR, Small Business. And these are grants that are allowed by groups like the U.S. Forest Service, by NASA, to look at and discover what's some of the cutting edge research that's coming out of small businesses, and to look at their research plan, fund them, look at their research plan going through a number of phases. Early build out of a new system, and then all the way to commercialization development. So there are funding available from the agencies to these industry partners, in particular small industries, minority-owned industries, to create or enable the creation of real-time improvements to technology capabilities that might be small sat systems that they're building out, or unmanned vehicle systems. So yes, we do look to industry partners and industry integration of their new and emerging space technologies or information technologies, information exchange technologies. So yes, very much so.
By the way, feel free to raise your hand if you want to ask a question or whatever too, that we can call on you.
Question. So I have a question here. I was fascinated by the talk and enjoyed learning more about uses of satellites. How can anyone intern at NASA? I see Lisa. Good. Lisa has responded to that question. There's intern programs. There's a couple of different intern programs that are within the agency. One of them is called the Develop, DEVELOP, Develop program. And that's where we take interns to work on projects at NASA. And this is in particular in the earth science realm. So the group that I'm with, to work on for about 6 to 8 weeks during various semesters on site, usually in non-COVID's era, on site at various NASA field centers or even within universities that are affiliated with NASA to learn and work with and to create their own project activities with partner agencies with NASA to basically intern and use their capabilities to mature up some new findings or new capabilities, such as this wildfire realm. We've had a number of developed students that have worked with us, come through the program and developed program, and worked with us on wildfire enhancements, how to make increased use of Earth observational data. So yes, there are plenty of opportunities.
There's a question from, or hand raised from Aurora.
I see that. What is the best part of working at NASA? The best part of working at NASA is, God, it's everything. It's working with some of the most brilliant people in the world, working alongside Nobel Prize winners that are, it's a fun place to work. The discovery of everything going on around you beside what you're particularly focused on. Working at a NASA center, there's other things going on, the creation of unmanned systems. New satellite platform systems, discovery of Mars. You're embedded in all that and you're part of that and you're made to feel like you're part of it. I don't know if people realize at your ages, but there's a survey that's put out every year across the federal government of what is the, which agency or organization, branch or whatever within the federal government system of over 23,000 different branches, offices, agencies, and the like. What do you think comes out as the highest ranked place as the most popular and happy to work for? It's NASA. It's amazing. NASA is the most considered agency for that provides the greatest happiness to their employees. It's just all around. It's just fun.
Let me add on to that. You get a chance to do some very cool things. For example, you know about the Mars rover that just landed, Perseverance, and it turns out my specialty is heat shields, things that protect spacecraft from burning up in the inner atmospheres. And my heat shield actually protected Perseverance to go into Mars. In fact, my heat shield is one that Elon decided to use for Dragon. And I was actually working with Elon and his team early days back in 2007, 2008, down in Hawthorne to transfer that technology. So Elon is using my heat shield technology on Dragon. So yeah, I get a chance to work with some, as Vince was saying, some amazing people on some amazing things. And again, there's, like any job, there's downsides. You guys will learn that. No job is all sweetness and light, and bureaucracies have their challenges. I worked for a very small company before coming to NASA, and small businesses have their attributes. There's a lot of flexibility. You get to be involved in everything, but there isn't as much stability. But I would agree with Vince that NASA has a lot of really positive aspects. And as he was saying, just from a from a broad standpoint from these surveys, NASA comes out on top time after time after time as far as employee satisfaction. So definitely something to consider as you get older and start looking at career paths.
I see a question up there about, is this technology only intended for the US, or is NASA planning on expanding satellite technology for other countries to help with firefighting? We do. Our satellite data, the MODIS and the VIR satellite data, is freely available and is shared throughout the world. Our web mapping services, you saw that FIRMS system, is a worldwide resource. And the algorithms that are developed are well-respected algorithms. The algorithms that are developed for the fire detection from those satellites are freely available and well-respected and have been around for about 35 or 40 years. So it's a very operationalized system. Our partners throughout Europe, throughout Asia, South America, Australia, the entire world is collected daily with satellite observation data from NASA, and those wildfire hotspot locations are fed daily to the entire globe over various web mapping services like firms. So that information is being used by almost every nation on earth that has a wildfire problem. One of the other cool sites you might want to check out is called GWIS, GWIS, Global Wildfire Information System. And that is basically similar to firms, where we share data for the entire globe on wildfire, current wildfire conditions, observations. And so you can look and see what fires are going on in Australia right now. You can look at the chemical concentration in the plumes there. You can look at the lightning strike detection data and a whole bunch of other variables that are shared with the entire globe.
There's a hand up by Vincent.
Let's see, maybe it's
Yes.
pass. Go ahead,
Yeah,
Vincent.
Vincent, you
Okay.
can go ahead and ask.
So yeah, working at NASA sounds really cool, but I'm from Canada and I know a lot of people at this hackathon are not from the US. So is there a way for like us, or at least me, to work at NASA one day, or do you have to be born in the US?
No, it's not restricted. We have interns in partnership from other countries as well, and we have employees from other countries. My program manager at NASA headquarters was a Russian-born who settled in Israel and then became a U.S. citizen. So yes, one of my colleagues was just went from being a cooperative university cooperator to a NASA employee, a NASA civil servant. He's from Puerto Rico. Of course, it's basically one of our sister states, if you will. So yes, we do cross borders and integrate people from all over the world.
And I should also mention that, you know, you do have the Canadian Space Agency as well, and we work with the Canadian Space Agency, so that's another route, you know, to take.
Yeah, and actually, we're co-developing with the Canadian Space Agency their own Canadian wildfire wildfire satellite system. So we have partnerships with the Canadian. Well, I in particular, and our wildfire community has partnerships with Canadian fire services, the provincial fire services, and with the Canadian Space Agency to co-develop and co-share some of these technology developments.
That sounds really cool. Thank you.
Okay, question. I don't know if it's, where do we submit our project to this challenge and when is it due for it?
That'd be Chantelle, I guess.
Yeah, somebody from AngelHack will have to.
Yeah, so you'll post on DevPost, so this will just be your project. If you want, you could also just send a link in the Discord if you want to share it as well, and also in presentations. So this will just be the classic DevPost submission.
Anything else? Is there existing, okay, question, is there existing map data sets that the fires data set that has fire spreading probabilities? If so, where can we get it? No, that's a data gap. The fire spread probabilities are individually prepared on the fire events by the incident management teams. And it comes from, the current capabilities are, it comes from kind of static map data layers and knowledge-based systems of wind speeds, wind direction, kind of micro environmental conditions on a particular fire event. What is going on right now? Some of the current research in fire monitoring is in creating real-time fire spread probabilities based upon all these variables like I presented, based upon terrain environments, computational fluid dynamics, so mathematical formulations of how a particular event will move through a given terrain with a given wind speed or temperature or a vegetation condition. So all these fire spread models kind of are starting to be matured more readily now into being real-time systems that take a lot of computational effort to run those into deriving kind of a real-time analysis of where that fire might move over the next 15 minutes, half an hour, 1 hour, 10 hours, 1 week period of time. So yes, there aren't any current map data sets that has fire spread probabilities. Those are all developed for individual fire events by the incident management team on that fire at the base camp. And those, as I said, do not currently readily avail themselves to the use of computational field dynamics and mathematical modeling. It's all information that's up here in the head of the local firefighters based upon their knowledge of the terrain and the vegetation communities. So it's a matter of coalescing all that information into digital space to allow that modeling to be available in real time and be computational rigorous and accurate. Is it Google Maps just satellite images? Yes, Google Maps is a combination of the NASA and European satellite data, and as well as aerial photography or aerial data collection imagery from private companies as well for some of the higher resolution data. It's also composed of commercial satellite data as well. Some of the higher resolution commercial satellite data are what plays into the Google Maps and Google Earth capabilities as well. And I should say that, yes, so Google does have access and utilizes the access of both agency satellite information and commercial satellite data, and other satellite services from our European colleagues, from the Indian Space Agency, the Japanese Space Agency, JAXA, and the like. Anything else? We're coming up near the end of our 1 hour before we switch over to the next. So let's see if I can see any other questions that are popping up. Yes, question, is it possible for, instead of satellites, using drones to be used for mapping out remote areas across the United States? Yes, that's a particular interest to the fire community. And I sit on a committee that looks at the integration of unmanned vehicle systems, whether small or large, high altitude or low altitude, for use in firefighting capabilities, for use in observing wildfires. And that's a particular focus right now within the fire management community, mostly because the satellite data that we have provides us strategic information. It's not at the fine enough spatial resolution to allow real-time tactical decision making. And it's only captured, at certain points during the day. So you don't have this continuum of data collection to keep an eye on the fire activity. That's afforded by drone aircraft, unmanned aircraft that can linger for a long time over a fire event, taking continuous imagery at much better spatial resolution, so we can see much more detail from that data set. I managed a program in 2006 through 2009 that used a large UAV with fire imaging capabilities on board to fly wildfires over the Western United States as demonstration missions for 3 years and provide real-time information to the incident commanders on the ground. And it was probably one of the most rewarding experiences of my life, being able to make that real-time decision tools available to the wildfire fighting community, incident commanders, to afford them the ability to really see in real time what was going on in their fire, like a live event. And so those technologies are being even further matured, and the firefighting community is adopting into operational use unmanned vehicle systems to do some of their resource inventories and their wildfire imaging. But that will continue to grow and expand dramatically over the next 1 to 5 years. Anything else I'm missing?
And Vince, you might want to mention on the drones, one of the limitations right now is knowing where they are relative to other assets. So it goes back to this real-time situational awareness as being an important aspect to be able to use them more effectively.
Yeah, that's why even though drone technology is considerably developed, we don't have the ability to integrate them into shared airspace with other platforms as readily. And it becomes a dangerous situation. It's basically the concept, and maybe we'll explore that in another challenge someday, is explore the concept of see and avoid technologies, or separation of airspace separation. How do we separate a fire retardant bomber flying through the air with a small drone that is coming through, and to deconflict the airspace issues? So that's one of the major hangups right now, why the technology, even though it's very mature, has not been fully integrated into operational capabilities, is the worst. The airspace issue is a worrisome context to approach. And so there we are. NASA is collaborating on efforts at NASA Ames Research Center with the aerospace community and aeronautics community to look at technologies to be able to see and avoid, to have intelligence on board platforms, to see and avoid other aircraft in their region of flight, and to deconflict that airspace issue. In particular, focus on this wildfire issue, because we see that in wildfires or in other major disaster events throughout the world, that unmanned vehicles being able to collect real-time information, linger for a long time over an event, are a critical component to remediation activities on those disaster events or the wildfire events. Am I missing anything? Anybody see any questions on there that I could hit? I'm looking at the chat.
I'd like to give up a little heads up. So
Okay.
I'm not sure, but our next workshop is going to be on a different link, just because that was the link I sent out. If that's okay. I'm really sorry. You could feel free to ask any more questions. I mean, are you going to be at the next workshop as well?
Possibly.
Yeah,
and
that's
I
really
will,
awesome.
I will be checking in during the day and
Thank you so much for being here.
Yeah.
Thank you so much for being an awesome mentor as well. I really appreciate it.
All right, thank you. And I'll be available through the day. Thanks.
Clap, clap, clap.